this beautiful entrance slide, jump back over to the first joke, and then now we're on to the second joke. This is math humor, right? So why are obtuse angles so depressed? And the reason is because they're never right. Naomi, surely you get this joke.
Yes, I do.
And surely you see how unfunny it is, right? You're like, this person is so lame.
No, it's an okay joke.
All right. Shanice, what do you think about the one on the bottom?
Sir, I find this one very funny.
It's very funny, right? Because
Yeah.
have you ever been in an exam like in that situation?
I won't even put myself in that situation to do math work in pen.
Exactly. At the very least, you know. So clearly, if you're gonna be doing it with pen, you like to live dangerously. So it's a meme. It's a funny meme. So I like it. And then here we go. We have another dark humor about climate change. And basically, you have a scientist giving a presentation saying climate change is going to threaten our existence. And if you look down here, nobody don't care. Everybody's sleeping. Everybody's like, existence, so what? And then now I'm saying, you know what? Rub it off, change it. Climate change is going to threaten our economy. And now everybody cares and it's a big deal and everybody's like, no, what are we gonna do to fix it? Because, and it's just showing you how crazy our response has been. Like if we don't show you how it's gonna affect the money, people don't care, people falling asleep, you know, but that should not be the case. Like it is going to threaten our existence and we have to do something about it. We have to take it seriously. We have to become researchers that study it, you know, so that's basically the crux of this joke. It's more like a political commentary, if anything. But let me go on to the next slide. So what I want to look on today and throughout the other math sessions, I don't want, because you know, math can be a little bit boring. It's not as fun as the robotics stuff, or it's not as fun as learning intro to microbiology, because I'm sure, have you done the microbiology class yet?
Yes, sir.
Yes, sir.
How was that?
Very
Interesting.
Very interesting, right? Did you do, well, I don't even ask how you guys did, because we're going to take up the math session talking about the microbiology. But yeah, it's like, we have so much interesting things there, but we also kind of have to ground it in a little bit of what you guys doing in school and how that's going to apply to your future careers. And you know, something as simple as math does matter. So essentially, what we want to basically get to by the end of this series with algebra is to understand how algebra can be applied to problems such as climate change, as well as the blue economy. And what I want to cover would be topics like simultaneous equations, how we're going to use that to make it relevant to climate change and the blue economy, quadratic equations, factorizations and expansions of algebraic expressions, direct and indirect variations. And that direct and indirect variations thing, it sounds crazy, but you know it. You guys know what it is, because the scenario that I have on the slides now has to do with that. And then, of course, converting real-world scenarios into algebraic expressions and functions. Let me ask you this, and I want to ask Kanishka. All of these things here, do you have, maybe not the variations one or by the name, but you have an idea of all of these topics already, right?
Yeah, I do.
Exactly. So right now we just want to focus, rather than teaching you what you already know, we want to focus on applying it to climate change. So quick and fast, what is climate change, right? Climate change, I wonder, let me ask you, are you guys seeing the Zoom thing that's hovering over the screen right now? Or no, you're just seeing the slide?
We're just seeing the slide.
Perfect, because I just wanted to make sure. All right, so climate change is essentially long-term alterations of of temperature and weather patterns globally. That's basically what climate change is. It is because climate is the long-term conditions of the planet in terms of, you know, atmosphere and those things. And then change is just alterations. So climate change is the long-term alterations of the status quo of the climate. And it is caused primarily in our time by human activity, such as burning fossil fuels. Can anybody give me any other example of one of the causes of climate change? Easy questions. Let me ask, I don't know, Shanice. I love calling on Shanice. Hello. Shanice.
Sorry about that. Yes, so what was the question again?
I was wondering if you can give any other examples of other activities that fuel climate change.
Pollution.
Pollution. Also.
I know that's very, very broad. So sorry. For instance, a vehicle that
Understand?
Yeah. Oh, sorry. A vehicle. Yeah. And then, you know, you'd have a more sustainable option with the vehicle fueled by hydrogen.
That's very cool. That's very cool. So you have so air pollution from vehicles, the carbon monoxide that comes out of the exhaust from the vehicles contributes to climate change because carbon monoxide is a greenhouse gas that's going to trap the heat and heat up the planet, right? Also, and that would fall under burning fossil fuels, you know, intensive agriculture, such as cattle farming, because when the cattle's flatulate, you know, everybody know what flatulate is, but when the cattle's undergo digestion, they release a whole lot of methane. So cattle farming is a big contributor to climate change. Large-scale monoculture, because you have to cut down a lot of forested areas and you're replacing the trees that are large carbon sequesters with crops that aren't as good at sequestering the carbon. Not to mention when you burn the forest in, for example, deforestation, if you're burning the forest, you're literally releasing all of that captured carbon in the tree back into the air. So things like that contribute to climate change. Now, the question that we need to answer further then, because some of us were saying that we don't know what the heck we're talking about when we say this blue economy. So let us try to answer. Thank you, Naomi. Burning of trees, exactly. So we want to answer, what is the blue economy? So essentially, the blue economy, and this is going to come up throughout your time in this camp, because the theme of the camp is climate change and the blue economy. So blue economy speaks to the sustainable use of ocean resources. So if you'll be using ocean resources sustainably, blue economy. Anything that has to do with using the ocean resources, that is a part of the blue economy. So whether you're using the ocean, you know, the oceanic resources for economic growth, or to create jobs, or for improved ecosystem health, however you use them, that falls under the blue economy. If you look at this beautiful picture here that summarizes it in great detail, it says up here, all economic activity related to oceans, seas, and coasts, that is the blue economy. So let me say that again. The blue economy consists of all the economic activities that has to do with oceans, seas, and coasts. We're talking about tourism. We're talking about city aquaculture. We're talking about shipping, you know, shipping and repair. We're talking about marine extraction of oil and gas, desalination, you know, that Prime Minister Andrew Holness wants to build a desalination plant out here. That's a part of the blue economy in Jamaica. We're looking at, you know, blue bioeconomy or biotechnology, a lot of things that e-Biome would really want to get into, looking at the different seaweeds and how we can use them as face soaps, or how we can use them as disinfectants, or, you know, ocean energy, hydroelectric pumps, all of that that has to do with using the ocean, the forces of the seas and the coasts and the oceans for economic advancement or to look after the ecosystem, that is the blue economy. So I hope that's kind of clear. And now what I want to get onto, because we end at 9:45, if I'm not mistaken, 9:45. So we have a little time, that's good. I want to go on now to a scenario, right? Because remember, the goal of what I want to get across is how we can use algebra with respect to climate change and the blue economy. So here we have a question that is more climate change focused. And I'm gonna ask you guys if you have pens and paper and your calculator, of course, if you're gonna need it, unless some of you can do it in your head, to work out this simple function with me, and you'll be able to see the relationship as to how and why algebra matters in these contexts, and how hopefully when you go off to university or you go off into whatever career you're going to go into, you can think when you have a problem, how can you write it down into an algebraic form to get a solution or to understand things better than if you just have the things in the word. So essentially, let's look at scenario 1. And this is a true fact, by the way. Scientists have found that since 1880 to the 1900, there has been a 2-degree, increase in average global temperature, in average global surface temperature. So now the question I am posing is, how will this fact, because this is scientifically proven, how will this affect the Arctic tundra or the temperate forests? Now, you guys know what Arctic tundra is, right? Well, yeah.
So,
You're not sure what an Arctic tundra is. So the Arctic tundra is basically, if you think about the Arctic, like the North Pole is described as the Arctic tundra. It's basically just an ecosystem that is devoid of readily available water. So it's like an ice desert. A tundra is an ice desert. So, you know, you have the Sahara Desert, which it doesn't have a lot of water. It has a lot of sand, but the point is that it just doesn't have a lot of liquid water that plants can use and animals can drink. So an Arctic desert or Arctic tundra is similar, only thing you don't have a lot of liquid water, you have a lot of solid water, but plants can't use that. And animals can't really drink that or live in that for very long. So it's just an ice desert. That's what a tundra is. And of course, temperate forests, I'm just talking about regular coniferous forests that have snow. So essentially, what I want to ask, let me see if this is working here. So what I want to propose is this function. So this is a function of snow cover in temperate areas. And if you can write this down, because we want to work this problem together, and I want to show you the relationship between, we're going to use algebra to show the relationship between rising temperature and snow cover. And of course, and snow cover. So we want to see the relationship between rising temperature and snow cover. This would be an indirect variation, but let's not complicate things with that. So let me know if you've written down the equation. It's going to be there for a little while, but we're going to try to work this out together. And in the following weeks, we're going to get more and more complex with the scenarios that we have and try to always link it back to the blue economy. How does that sound? Naomi, sound good?
So can you repeat what you said?
Oh no, I'm just wondering how does that process sound that we're going to do? You know, where we're just going to increase the difficulty from time to time and try to apply it a little by little as to how, you know, what we can do with algebra. So you say it sounds good. Very good. Thank you. I feel like I'm boring you guys to death. Oh my gosh. Let's get
No,
on to the math. Yes, thank you, Shanice. Lord, give me something. All right. So anyway, now what we're going to continue with is with this function. So the function is z equals 2 bracket 3y over 4x. Now we know what algebra is because we touched on it yesterday. It's basically where we're replacing actual variables being x, y, and z, that those are values that can fluctuate up and down, they change. So replacing these variables with letters to make it easier to work with mathematically, right? So here, z represents the snow cover. And because snow cover is a volume, because you're wondering what's the volume of snow that's going to be left in these, in a temperate forest, for example, in a snowy forest, like if you think of the forests in Russia, or you think of a plain in the Arctic tundra or up at the North Pole, where it's cold and you have snow, a lot of snow. So we want to know, like we're looking at the volume of snow. So it's in kilograms per meter square, because you know that volume is mass per, you know, square meter. That's basically how you find volume. And then of course, X would be the temperature in degrees Celsius, and precipitation or snowfall would be, well, Y, and that would be in centimeters. Typically precipitation is in millimeters, but snowfall by and large is measured in centimeters as well, because of the quantities that you end up with, because it's not like it's leaking down onto underground or anything like that. All of the snow that falls is going to stay. So you're going to have a lot more millimeters of coverage. So it's better to just use centimeters. Anyway, let us look at the real question and see if we can work it out. So I hope we wrote down the question, and I want to give you guys a little time. It looks like we might not even get to go on to the second scenario, but that's okay. So let me read over everything again. This function is a function of snow cover in a temperate forest, right? And the function is z equals 2 times 3y over 4x, right? So, and then of course we know what z is, x is, and y is. Now, if the precipitation, or at least snowfall, if the precipitation in this particular temperate forest is 121.5 centimeters, and the temperature increases by 2 degrees, as scientists have found. So what is the snow cover in that particular forest? That's the question that we're trying to answer. How would we go about tackling this question? I want to ask, let me ask Kanishka, how would we go about tackling this question?
I don't know.
You're not sure?
No.
All right, let me try. Let me see Naomi. If anybody, is anybody sure? Let me ask Naomi, what you think? How do you think we can start tackling this question? Because we have this function, and we have here what each of these values mean. And then we have this scenario, and this is based on real world data. So let me see, Ivanka, what do you think?
I don't know.
You're not sure? All right, well, let's go on. I mean, I'm actually a little bit glad that you guys aren't sure, because now, no, let me ask Shanice. Shanice probably knows. Come, Shanice.
Sarah, would you replace the known figures in the function?
Yeah, what you say, you replace the known figures with what?
In the function.
In the function, exactly. Exactly. What we're going to do is basically, we are going to take the real world figures that we have, because this figure, I didn't make it up out of my head. This 121.5 centimeters, that is the average annual snowfall in Toronto, Canada. So this is a real world number, right? And 2 degrees Celsius, that is how much our Earth has increased temperature by. So let's, take everything else for granted and just want to see what would the snow cover be at this temperature given this function. Well, we're going to substitute in the values. And when you substitute in the values, you end up with this. You have Z, which is snow cover, is equal to 2 multiplied by 3, that is multiplied by 121.5, and that is over 4 multiplied by X, which is temperature, right? Work this out and tell me what you get. Wait, let me ask, you guys have your calculators, right?
Yes, sir.
All right, perfect. So work this out and tell me what you get. And then I will ask, you don't have yours on you, Naomi. Do you have your, if you have your mobile phone, you can use that as well, because you can just work out the top half and then whatever you get for that answer, you divide it by the bottom half. So let me see, give us a little bit of time. We have a little under 9 minutes. So it looks like we're probably just gonna go over one scenario today. And then next week, so for the rest of the sessions, we're just gonna do scenarios like this for you guys to get an idea of how algebra and these things are relevant to us, But anybody have an answer yet? No? Kanishka? Ivanka?
No, sir, I'm still working.
Still working? All right.
Sir,
Yes.
I got 91.125.
Yeah, I got the same.
You got the same? Perfect, perfect. Naomi? Are we getting that? I'm gonna show the next step here, because that's basically simplifying it down a little bit further. Yes. And Ivanka?
Yes, sir, I finished.
What did you get?
91,125.
You say you get 91,100 and... So go with that again.
What did you say?
No, I'm just asking if you could repeat the answer that you got.
91,125.
Okay, but you're very close, You're very close. I think where you may have gone wrong is that there's something in the calculation where you went wrong, that because you have the right numerical values, but the decimal point is off just by a little. Because if we go to the next one, we see that it is actually 91.125. So it's just 91.125, but I think you say you have 91,125. So your point is not where it's supposed to be. But we can see it's just basic arithmetic. You're substituting the values for what you have here. You plug it in where you have the variables. That's what you got, Naomi? Perfect. So you plug in the variables and you end up with the answer, which is 91.125 kilograms per meter square of snow cover. Now, let us get to the point and show you how climate change can be damaging. So I want you to remember the function. It's going to be on the next slide. But remember that temperature has increased by 2 degrees Celsius. But global warming is an ongoing process. So what will happen if instead of 2 degrees Celsius, a couple years down the line, the temperature increases by 4 degrees Celsius? How much snow cover would we have then? Well, all we have to do is, oh, by the way, here's a picture of the Arctic of like a temperate forest. This will be a temperate deciduous forest. I don't know how many of you guys do biology, but that's what I have my bachelor's in. So I know if you hear me talking all of these ecology terms, it's because I've been doing it for so long. So it's just ingrained in me. Yes, so you just plug it in again. And what's the answer that you get here? I wonder if maybe this time around, I wonder if Kanishka, you have something?
Can you repeat what you said? I didn't hear you.
Oh no, all right, let me see here. Let me try fix, maybe my audio bad for you. Okay, there we go. So we've increased, so climate change is continuing, right? So we were working with data. Let me go back. We were working with data from between the 1800s and the 1900s, right? And it has increased by 2 degrees. Now let's say, God forbid, that the global annual surface, temperature has now increased by 4 degrees Celsius because climate change is ongoing. What would the level of precipitation in this area, based on this function, based on this algebra that we're using, what would the snowfall in this area be? So the last time X was 2, because it was 2 degrees, because remember, X is temperature. So now what is snow cover since X has now risen to 4? And you basically just, you work out what's in the bracket first, 3 multiplied by 121.5, and then you multiply that product by 2, and you divide it by 4 by 4. If you notice, it's the same number on the top, but the denominator has increased. Since the denominator has increased, what type of result do we end up with? Shanice, you have an answer?
Yes, sir. Let me just put my book. I got 46.40. Where is it? 45.56.
45.56, and that is indeed correct. 45.563, because let us keep it to 3 decimal places. But if you notice, we increased, and this is very important, and this is how you're supposed to look at it. Temperature only increased by 2 degrees Celsius, right? 2 degrees Celsius, but the snow cover, the amount of snow that covers, one of these forests, it has gone down by nearly a half, because it was 91, by more than a half, I think. It was 91, more or less, and now 2 degrees, a 2 degrees Celsius increase in global surface temperature has now gotten snow cover down, or precipitation in that area, because it doesn't only apply to snow cover. Based on this function, it has gone down to 45 kilograms per meter cube. So you can see the issue here with climate change, and you can see how the numbers kind of show you, it shows you how these things happen. It shows you what the relationship is. Now, I wanted to challenge you, because I don't have the answer here, I just have 2 more questions. I'm wondering if now, based on these previous examples that we did, just before we end off the session, because we have 1 more minute, but can you tell me what would happen, ballpark, maybe you don't even have to work it out, But I just want all of you, I'm gonna ask Ivanka, what would happen if temperature were to increase? This says 4 degrees Celsius, that's what I have here. But what would happen if it were to increase by 8 degrees Celsius? What would be the average snow cover? What would happen to the average snow cover? Would it increase or would it decrease?
It will increase.
The snow cover would increase or would it decrease? Because if the temperature increases, what's going to happen to Z, the snow cover?
It will decrease.
It will decrease. And of course, if it increases by one, degrees Celsius, what's going to happen? Obviously, it's going to, temperature is increasing, it's going to decrease as well. Now, what we want to look at, the time is done so fast already, but because temperature is in the denominator, any increase in temperature or any increase in a denominator value will lead to a decrease in, the overall, what the function equates to. So any increase in temperature will lead to a decrease in snow cover because it's in the denominator. If you were to decrease the temperature, therefore, if you were to go from 4 degrees Celsius to 2 degrees Celsius, you decrease what's in the denominator, you will be increasing what is the amount of snow cover that you end up with. So essentially, that's one scenario. I had a whole other scenario as well, but given the time and everything, and you guys have the next session, we can just end it there. You guys probably won't even see me next week, but you will see my scenarios, and hopefully you can have some sort of appreciation of how algebra can be used to represent real world situations in terms of what's happening right now. You have animals that depend on a particular environment for them to survive. If the snowfall falls in half, precipitation fall in half, imagine no rain. Rain we're getting now, we get half of the rain. Drought, madness, can't live, right? It's similar for those animals that are in the snow or those ecosystems. It's being torn apart by climate change.